Whole day on slope. We spent a whole bunch of time in the last unit talking about rate of change, which was what? Slope. And here we are talking about slope again. Once again, I ask you, how important is slope? Very important. So, slope equals a whole bunch of stuff. Who can remember one thing that slope equals? Rise over run is one thing. Who can remember another one? Josh. Change in y over change in x. Absolutely. Or in physics, they say delta y over delta x. Anybody else? Pardon me? Yes, the change in the dv over the change in the iv. Anything else? y2 minus y1 over x2 minus x1. And there's one last thing that slope is. You've seen it. It's in one of the equations. M. Is everybody good? All those things are slope, which means any one of those things you can use will get you slope. You can use any one. That is how many? 1, 2, 3, 4, 5 different tools to find slope. Yeah? All right, let us do so. We are going to draw 4 lines on this graph. Those 4 lines are going to be, you don't need to use colors. I will, though. E. We're going to do E first in this section. Everybody put their pencil no, that's a lie. I don't want to do it that way. Everybody choose a number in their heads. Do not yell it out. And even though I've said this, 5 of you are going to yell it out anyway. Choose a number between 0 and -7. Do you all have the number in your head? You all have it in your head? Write it down. My number is -3. If you have -3, don't tell me you have -3. Just write down your number. Now choose a number between 0 and +7. Don't say it out loud. Just write it down. Everybody got it? Mine is going to be 1. Now, I have a number, comma, number. That is a point on the graph. Everybody put a dot at your point on the graph. Yeah? Now, I want you to draw me a line from that point that has that slope. You have 7 ways of talking about slope. I lie. 1, 2, 3, 4, 5 ways of talking about slope. One of those 5 ways applies to that. You try to draw me a line that has that slope starting from your point. Which color is the one that applies to the situation we have right now? The yellow one. Rise over run. It is a fraction. So its rise is +2. How will I show a rise of +2 on mine? And all of you will do the same thing. Up 2. 1, 2. positive 2. How will I show a run of positive 5? Go to the right, 1, 2, 3, 4, 5. Making that, oops, that was a bad line. That line. Every single one of you, or what else could I have done? I could have gone negative 2 and negative 5, because negative 2 divided by negative 5 is positive 2 over 5. Every one of you should have a line that looks like that. Does everybody get it? Great. Draw 3 more. I'm going to make blue will be F. That will be down in this quadrant. Green will be G over in this quadrant. And H will be whatever color you would call that over in this quadrant. Go. About 10 more seconds should be enough time, because what is the only math I have asked you to do here? Count. When did you learn to count? Anybody get that joke? Yeah, I got it. Okay, just making sure. Do you know why they call me the count? Because I love to count things. There is your drawings. Okay. I am not trying to put you down. I am not trying to make fun of you in any way. But, again, what am I asking you to do here? Count. What is that really? Negative 4 over 1, which you learned in about grade 4. So, is that a fraction? In slope, fractions are rise over run, correct? So you start at any point, you rise 4, and you run negative 1. One of the directions has to be negative. If I started up here, I would have dropped 4, which is negative 4, and run positive 1. This one, 0. I rose nothing. And I went this way, 1, 2, 3, 4, 5. 0 over 5. Is that allowed? Yes, because I have no pizza in front of me. Let's split it, Jovan. You want half? How much pizza is he getting? None, because I got no pizza to split. And the last one, positive 7. So I went up 7, positive, and right 1. All you have to do is count. Positive slopes lean to the right of straight up and down, because rights are positive. Negative slopes lean to the left of straight up and down, because left is negative. Rise over run, 0 up and down, and I ran, this case, 5. Now that you all have seen that, I want you to do one more, somewhere by yourself, because a bunch of you didn't get this done, because you didn't know how to do it. Give me a slope of negative 4/3. You can start it anywhere you want. Put a dot, put a second dot that is a slope of negative 4/3. There is my first dot. How do I make a slope of negative 4/3? I rise 4. Now, if I went down 4 because it's negative, I'd be off the graph. So can I do that? No. So I go up 1, 2, 3, 4, positive 4, but I need my slope to be negative. So one of my directions must be negative. So do I turn left or right here? Left. And I go how far? 1, 2, 3. And this is my slope. These are not part of it. This is the line. This is how I find it. Is everybody good? Awesome, possums. Now, in all 5 of these, I let you choose your starting point, didn't I? So all you had to do was go plop and count. Agreed? In the next 2 examples, what is the only change? I am telling you the points, aren't I? So, how do I get to there? I'm going to zoom in to make this bigger for you guys to see it. How do I get to that point? Left 5. 1, 2, 3, 4, 5. And then what? Down 1, 2, 3. Agreed? Do I have a line yet? No, I only have 1 dot. How do I get to the second point? 2 to the right, 1 up. Agreed? Now I have a line. Is it on the graph? Oh, I knew you're killing me. Is it on the graph? So to find the slope, what is the only skill I need? Counting. Let's count. I want everybody on that side of the room. You have to count from this point. This is the window side of the room. Everyone on the hallway side of the room has to start at this point. Go. Don't yell out an answer, just write it down. On the hallway side of the room, rise over run. Where am I going to go for my rise? Down. 1, 2, 3, 4. What is my run? 1, 2, 3, 4, 5, 6, 7. Down is negative 4. Left is negative 7. What is the slope? Negative 4 over negative 7. 2 negatives make a positive. If you were on the window side of the room, you started here, and you went up 1, 2, 3, 4, which is positive 4, and right 7, which is positive 7, to get a slope of 4/7. Does everybody understand? Does it matter which point you start from? No, as long as you know that up is, and down is, and right is, and left is negative. Okay? Let's do the second one. Where are the points? 0, negative 4. Where's that? Down. 1, 2, 3, 4. 0, 3. Where's that? Up. 1, 2, 3. What's my rise? Positive 7. What's my run? 0. Can you divide by 0? No, because that is an infinite slope, because it is not a slope. If I tried to ski that, I would fall. Okay? That is what we call an undefined slope, because it is infinite. Everybody understand? You all understand why a flat one is 0 and that is infinite? Good. So, to recap, to put a slope anywhere on the graph, pick a point, Count, rise, and run. Right? To find the slope between two specific points, if they're on a graph, what do? What did we just do? Make the triangle. Count, rise, and run. Turn the page over. What's happening here? Do I have a graph? No. Would I be allowed, if I wanted to put this on a graph? Of course I would. I would go out to 2 and up 7, and I would go over to -6 and up 1, right? And then I would just count. Yeah? But that's crazy. Why would I go to all that trouble? Because I know that slope is rise over run when it's on a graph, but I also know it's the change in y divided by the change in x. What math shows me a change? Subtraction. y2 minus y1 over x2 minus x1. Why is there a 2 and a 1 and a 2 and a 1? Because there's an x value there and a second x value there. If I make them both x, they would both have to have the same number, wouldn't they? But they don't. So it's x1 and x2. Who decides which is which? You do. Everybody on the window side of the room, that is x1. So what does that make this? y1. What does that make this? x2. What does that make this? y2. Everybody on the hallway side of the room, you're reversing it. This is x2, y2, and this is x1, y1. Do your math. M equals y2 minus y1 over x2 minus x1. You fill it in for your appropriate side of the room. In black, which is the window side of the room, it is 1 minus 7 over -6 minus 2. What's 1 minus 7? -6. What's -6 minus 2? -8. Two negatives make a 6/8. Would Mrs. Bad Crumble ever let you leave that fraction? No, so what is it? 3/4. Now, in red, let's do the other side. Change it around. y2 is now 7. 7 minus y1. 1 over x2, 2 minus x1, minus 6. What's 7 minus 1? 6. What's 2 minus 6? 8. 3/4. Does it matter? No. What does matter? If I make that x1, this has to be y1. Everybody with me? Great. Prove it. You guys do L. If you label it, it is impossible to do wrong. Label it however you want. Yeah, that works perfectly when the graph gives you perfect numbers. It's a little hard to do the graph when it's 1.73 and 4.97 and 8.23 and 28.17. So the way I have labeled it here, what's going in for y2? 4 minus what's going in for y1? 15 over what's going in for x2? -1 minus what's going in for x1? -5. 4 minus 15 is what? -11. 1 minus -5. +4. -1 minus -5. +4. That's my slope. Can everybody do it? If it's on a graph, you count. If it's not on a graph, you do this. Everybody good? Ease peasy lemon squeezy, right? Okay. Let's add another wrinkle of difficulty, like we always do. We build on what we started with. Are these on a graph? So we should be able to count them, yes? Okay. So A, could I count from that pink dot to that pink dot? Really? Okay. Count. How far down did I go? Yeah, go. 13? Exactly? No, why not? Because they are not on the points, are they? Do you have any idea how far this actually is? No. Do you have any idea how far this actually is? No. So you cannot use the end points. So what should you do? Pardon me, Hayden? Yes, use a point where you know the values. Tell me when I can stop my pen. Tell me when I can stop my pen again. There? Now, can I find the slope? Is it on the graph? So how do I find it? Count. What's the rise? If I start down here, what's my rise? 1, 2, 3, 4, 5, 6, 7. Positive or negative? Positive. Then count my run. What is it? 1, 2. Positive or negative? So what's the slope there? 7 over negative 2. What if I go the other way? Start here. What's my rise? Negative 7. What's my run? Positive 2. So my slope would be negative 7 over 2. Are they the same thing? Could I also write it this way? Negative 7 halves. Could I write it this way? Negative 7 over negative 2. No, because that's positive. Everybody with me? Yes, Javon. Of course not, because it's rise over run, not run over rise. What about B? Should I choose, can I do end to end? No. Should I choose 2 points very close together, or should I choose points as far apart as possible? As far apart as possible. Where can I stop my pen? Right there. Where's the next place I could stop it? There? Or there? Is this an exact science? No, because some of you felt I could stop there, some of you felt I could stop there. Okay, so what's the slope of B? If I go from here, do I go up or down first? How far? 2, 3, 4, 5. Then what? Right, how far? 3, 4, 5, 6, 7, 8, 9, 10, 11. If I started here, what would I do? Negative 5 and negative 11. Everybody good? And the last two you can just get by looking at him. What's this guy's slope? Don't even need to count. What is he? No. This is undefined because it's not a slope, it's a fall. And this is 0 because it's not a slope, because if I was on a snowboard, I can't do anything except hop like a bunny. While every skier goes by you and you think you're cooler than they are. Everybody good? All right, now you've seen 2 ways to find slope, counting on a graph and using algebra. Which is the more exact way to do things? algebra, because if you have a fraction, it will work. Everybody cool? All right, turn the page over. Oh, don't turn the page over. You got to do number 4 first. Try to draw a triangle that has 3 sides that are a positive slope. If it helps, start with that. No, a triangle. All 3 sides have a positive slope. A triangle cannot have a slope. It's 3 different lines. Why are we talking like Thanos? Just for fun?
It's a lot cooler.
How is that a positive slope?
It's not a negative.
How many people are having some trouble with this? You have all the time you need. I'm just asking if anybody's having trouble with it. I need to start, don't I? How many sides do I need to start a triangle? 1. So I'm going to draw 1 positive slope. There's point 1. How would I make a positive slope from there, Maddie? Up and over. That doesn't help me. Right or left? Up and right. Are you happy with that? Happy with that? Now I need a second line, don't I? That still has to be positive. So I'm going to start here. Where do I need to go? Up and right. Is that still positive? Now let's check the third point. Here to here. Is that up and right? So is it positive? Easy peasy lemon squeezy, yeah? Why would I get you to do that without dots? To show me that you know what a positive slope looks like. What if I told you I wanted them all to be negative? How would it change? It would be down and left. So, point 1, down left. Yeah? Then, down left. Negative, negative, negative. Is everybody good? Excellent. Turn the page over. We are going to do what we did yesterday. Well, not yesterday, Friday. What do we know about every single x-intercept? Every single x-intercept in the universe. What is it? He waited patiently. Okay, I'm going to put 5 dots on this graph. You tell me which ones are x-intercepts. There's a red one. There's a peachy one. There's a gray one. There's a green one. And there's a purple one. Which one are x-intercepts? Purple, peach, and green. What is the characteristic they all share? They're all x something and 0 for y. All of them. Now, that should help you out when I ask you what a y-intercept is. What is a y-intercept? 0, y. Now, in grade 9, you were taught the T-chart. These are what? What is on the left of a T-chart? X's. In grade 10, I told you that's input or independent variable. What's on the right? Y. In grade 10, that's output, dependent variable, or the f of x, yes? Okay. If those are x's and those are y's, what do you see there and there? X's and y's. The next 3 units require you to understand that incredibly complicated concept. X's, X's. Y's, Y's. Can you dig it? 3x. What is my x value? Dude, what is that? That's an x. So what is my x value? X. 3x minus 2. What's my y value? 0. Plus 8 equals 0. If I'm looking for the x-intercept, does the y-coordinate even matter? No, of course not, because 2 times 0 is 0, so it's out of there. 3x plus 8 equals 0. Anytime you see that, am I looking for 3 x's? What am I looking for? 1x. So what do I do to that? Algebra. Go. What does x equal? X equals negative 8/3. Do I see an x right there? So what's my x-intercept? Negative 8/3, 0. Great. What's the y-intercept? X is 0. Do I care about the x then? No. So it's 3 times 0, which means I don't care about it, minus 2y plus 8 equals 0. Am I looking for negative 2 y's? No, I'm looking for a single y. So what do? Algebra again. Negative 2y equals negative 8. What does y equal? Four. What is the y-intercept? 0, 4. Now, let's put it on the graph. Which of those two is a real pain in the behind to put on a graph? The x-intercept. But it doesn't have to be a pain, does it? Because who's in charge of this graph? You are. If you make this 1, then that makes 8/3 really hard to find, doesn't it? But if you make this 1, then that makes it really easy, doesn't it? Because if I make this 1, what are each of these squares now? 1/3. And I need to go where? Which 8/3? Negative 8/3. 1, 2, 3, 4, 5, 6, 7, 8. And there is my x-intercept. You've shown me that you've changed the scale, so now you're in good shape. Yeah? Now, can I keep that scale for the y's? No, because if I was keeping that scale, how many thirds do I need to get to 4? I would need 12. Do I have 12 spots on the y? No, so I cannot keep that same scale, so I'm going to say this is 1. Where does my dot go? At 4. 1, 2, 3, 4. Everyone agree? Now I can connect that line. Now here is where you are all going to make an error because all of you stopped listening when I said, when it's on a graph, you can count it. What's the slope of that green line? What's the slope? Other way around. 4, because you do rise of 4 over a run of what? Is that 8? No, what is it? It's 8/3. So it is 4 divided by 8/3. Everybody understand? Even though it's on a graph, because the scales are different, we can't count it. Have we seen this before? Yes. Remember back here when we were talking about rates of change and the scuba diving lady. These were different scales, right? No, the scuba diving lady wasn't different scales. Which was different scales? This one. The watering can. We had to look at actual values, not numbers of squares. Everybody cool? Sweet. So I'm going to stop for a moment and make sure everybody is good there. Can you all find an intercept? You just substitute in x0, 0, y. Yeah? Everybody understands why I cannot count squares here. I have to count values. Everybody understands that? I'm being very serious right now. I'm not doing that thing where I go, it's only this, why don't you get it? I'm being very serious here. Can everybody do this into there, this into there, and recognize that it is not just counting if the scales are different? Is everybody okay? Okay. That, ladies and gentlemen, are the only skills you need to do the next 3 units. Yes, way. That is all you have to be able to do. Substitute values that have x and y into an equation that has x and y, put it on a graph, and measure values. Can you all do that? Awesome. Let's go down to this question. Notice I have blank space and a graph, yes? That means on one way you can do this algebraically. Does algebra always work? Yes. You could also do it graphically. Have we had examples where the graph didn't work very well? Yes. We're going to try both of them here. So, what do you see in this question? What is that? But what is it? It's an x value. What is that? A y value. What is that? An x value. What is that? A y value. What is that? Slope, which is rise over run, and y2 minus y1, and delta x, delta y over delta x, and delta dv over delta iv, and m. Do we have an equation that uses 2 x's, 2 y's, and an m? Do we have an equation that does that? M equals y2 minus y1 over x2 minus x1, correct? Well, fill it in. What's m? 2. Since it's a slope, it should really be rise and run, shouldn't it? So what should go under here? 1 equals y2. Which one of those is y2? Does it matter? We just proved that earlier. So which one of those is y2? It doesn't matter. But if I label it, it makes it impossible to do this wrong. Can you gentlemen leave? Just go. No, out. Yes, go. Go away. Go away. Yes, go away. I do not care where you go because you don't care about math, so I don't care where you go. Goodbye. Close the door on your way out, please. Thank you. What is this? You want to make that one x2? That's terrific. Josh, what does that make this y? y2. What does that make this x? What does that make this y? y1. What do you see right there? y2. So what number am I writing? 6. Minus y1. What do I write there? Y. Over x2. What do I write right there? 2. What do I write right there? Negative 4. Tidy this up. 2 over 1 equals 6 minus y. What's 2 minus minus 4? Try again. 2 minus minus 4. 6. What do you do in algebra whenever you have fraction equals fraction? We spent the whole first unit doing this. Nope, that's for adding them. Multiply how? Say it louder, Maddie. Cross multiply. What's 2 times 6? 12 equals. What's 1 times 6? 6 minus what's 1 times y? Y. What should I do there? Am I looking for a negative y? What am I looking for? I'm looking for a y by itself. So get that y by itself. What do I do with that 6? Minus 6 from both sides. 6 equals negative y. So what then does y equal? Negative 6. Is everybody good? That's algebra. Is everybody good with it? Yes? Prove it. Go to the next question and do this one with algebra. And after you do that one, go to number 8 and do that one with algebra. Then we're going to go back and talk about all 3 graphically. If you label it, it is impossible to do it wrong. Has everybody at least done 7? Okay, I'll wait a moment to make sure you've finished 8. Meanwhile, I'll put 7 on the board in case you wish to check it out. Is everybody good? Everyone is okay? Now, of course, it could have gone this way. x2, y2, x1, y1, in which case you would have had negative 3 over 2 equals 5 minus 4 over negative 1 minus x, which would have been negative 3 over 2 equals 9, negative 1 minus x. Negative 3 times negative 1 is 3. Negative 3 times x is positive 3x equals 18. 3x equals 15. And x equals 5. You could have done either way. Is everybody cool? Everybody able to do the algebra? Yes. It doesn't matter. You can put that on the left or that on the left. It doesn't matter. Is everybody cool? Okay. Now I'm going to slide down to number 8. I have it done one way. I'm going to do it now, of course, the other way, so you can see that it still works. If I change this to x1, y1, and x2, y2, then I get 3 over 1 equals negative 5 minus 7 over 0 minus x. 3 over 1 equals negative 12 over negative x. Cross multiply. Negative 3x equals negative 12, and x equals 4. Can everybody do the algebra? If you couldn't do it yourself, can you follow it at least? Is everybody cool? Okay. Now, we already know what's better, algebra or graphing? Algebra. But we're going to solve this with graphing anyway. So go back to the very first one. Do I know where that spot is on the graph? Take me there, Jovan. So where do I go? Just this point right here. 2 to the right and up. 1, 2, 3, 4, 5, 6. Agreed? Okay. Do I know anything about the other point? I only know the x value. What is it? Negative 4. So it has to be somewhere on this line, doesn't it? Does everybody follow me to there? Okay. Do I know anything about else? I know it's got a slope of 2, yes? Down 2 over 1. Is that 2? Negative 2, negative 1. Is it? Can I do that again? Can I do it again? Can I do it again? How long can I do that? Forever. But why do I stop there? Because that gets me my x value of negative 4 and a y value of 1, 2, 3, 4, 5, negative 6. Is everybody good? Try it with the next one. Put the point you know, put a dotted line for where else you know, and figure it out. Go. Is everybody good? Yeah? Okay, now do it with 8. without me showing anything. Can everybody do them both? Stop now and ask if you can't. You know as well as I do that if you are having some trouble, there's a decent chance someone else is too. Can everybody work both of them? Lennon.
What was the answer for number 8?
For 8, it was x equaled 4. No. Is everybody good? Now, I started down at 0, -5. I needed to get all the way up to where y was 7. Up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and there I am. Is everybody good? I just made the mistake that I always talk to you guys about. I said up and over. Up, right. Up 3, right 1. Up 3, right 1. Up 3, right 1. Everybody cool? All right. Now, let's go to 1. Yes, Josh?
Where did you start? Did you start at 4?
I started at 0, -5, because that was the point that I knew. Up, 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 up. Everybody cool? Okay. Now, let's go to this one that is troublesome. And we'll talk about why it's troublesome in a moment. Which way always works? Algebra or graphing? Algebra. So let's do algebra. What are we going to make this guy? X2? Okay. So that makes this guy what? Y2. What does that make this guy? X1. What does that make this guy? Y1. What does that make this guy? M. Let's do our math. 5 over 2 M equals Y2. Y minus 2. Does everybody know why it's minus 2? Right? Because the formula is Y minus, whatever the Y value is, and this value is -2. Over, what's X2? 2 minus what? -3. This is barfy. Let's tidy it up. 5 over 2. What's y minus -2? Y plus 2. What's 2 minus -3? 5. Fraction equals fraction. What do I do? Cross multiply. What's 5 times 5? 25 equals. What's 2 times y? 2y plus what's 2 times 2? 4. How many y's am I looking for? 1 y. So get this to have 1 y. What do I do with the 4? Minus. I bring it over here. 21 equals 2y. Everybody still cool? And what do I do now? Divide by 2. So y equals 10.5. Everybody understand? Now, that will be difficult to solve graphically, won't it? For 2 reasons. 1, do I even go up to 10.5? I can't even do it graphically, can I? Because it will go off the graph. Now, if I wanted to do it graphically, I would go to -3, 1, 2, 3, -2, right? And I would need to get out to where x equals 2, correct? And my slope is 5 over 2. So 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. 1, oh, I can't even do it. unless I change the scale. Is everybody good? Now, I could find it logically, though, couldn't I? Even with the graph. Because here is where the graph ends, right? And that is 1/8, correct? Everyone agrees? And I know I need to go up 5. What's up 5 from 8? 13. So I would be up at 13 on the Y scale. And I got to run 2. What's 2 run away from 1? 3. So you could find it that way. Oh, wait. That would be the next point way up here, right? At 3:13. Everyone agree? But I don't want 1 or 3. What do I want? 2, which is right in the middle. So I would need right in the middle of 8 and 13, which is 10.5. 8 and 14. Is everybody good? Which way always works? Algebra. If you're doing a physics question with a bunch of decimal points, would you try to do it with a graph? No, what would you use? Algebra. If you had exact points that fit on your graph, could you do it graphically if you so chose? Yes. Now listen to me carefully, please. This is going to get weird. There was no new math today, was there? Algebra, counting. Page 196 has practice questions with answers, as always. Okay? Do some of it. I don't care how much, but I would recommend you can do the last couple. 17, 23, and 28. You do as much of that as you see fit. On page 198, what do you see? Practice. Are there answers? No. This is what I want to see tomorrow. If you get what we're doing right now, you don't need to do 197, 196 and 197. Go ahead and move on to 198. If you're a little dodgy, try a couple from 196 where you have the answers and make sure you're good to go. Okay? So what is the stuff I have to see done tomorrow? 198. What should you make sure you've done a couple of while you're here with your friends and me to help? 196, unless you're right, ready, good to go. Everybody cool? Yeah? Okay. Go.